I'm Brandon Humphries with Mashburn Construction. I am the Director of Pre-Construction for the Upstate office, and today I'm here to talk to you about estimating prior to new technologies such as Building Connected and ProEst. Prior to Building Connected, we used to have plan rooms where different subcontractors would come out and measure their scopes of work and confirm quantities for each bid that they're submitting a proposal on. Once they've taken off their quantities and gotten their numbers, they'd send us their proposal, and we would review it compared to our takeoff and evaluate the bids for each project.
Hello, my name is Tyler Walker, and I'm a pre-construction manager with Mashburn Construction out of the Greenville office. I'm here today to talk to you about some of the emerging technologies that we're using for pre-construction across Mashburn as a whole. The two technologies I'd like to show you are both web-based applications. The first being Building Connected, which is where we house information for our subcontractors and also organize our subcontractor quotes. Here you can see I've got an individual job pulled up that has the divisional breakout for all the trades that we expect to receive pricing from. It's labeled as bid packages. We can also message the contractors through Building Connected, similar to email. Files are where we upload the drawing specifications and any addenda, things of that nature, so that the subcontractors have access to them. Information is general information on the project as far as location, bid dates, RFI deadlines, and things of that nature. Bid forms are where we can generate a individualized bid form per project and per trade to send out so the subcontractors know what we're expecting for them to price for the job. Team is where we can assign our team members different trade packages within the job, but you can see that this was a one-man show. And then reports are just for post-project use. It shows subcontractor coverage, things of that nature. So quickly clicking into, let's say, drywall for this project, you can see that we issued this out to 6 subcontractors and received 2 prices. Previously, I'd brought up the bid form. You can see here that we were looking for a breakout on drywall and ACT cost, as well as 2 alternates. And then I've included a list of inclusions that I expect to be priced so that I know that a subcontractor has total scope coverage. As we go into bid leveling, we can see the 2 bids that we had, see the different prices that they've put in, as well as where they've clicked that they did or did not include everything. Here you can see that they've included everything, so we know that both these prices should be full scope and are good to go. If they weren't, we could come into other costs and change the values, take away or add to make sure that these 2 guys have priced the same thing.
Way prior to Building Connected and ProEst, we used to use actual blueprint drawings to complete takeoff and scope out jobs. In doing so, you would use a scale ruler to find the correct scale of each drawing, and then you would come in and actually measure out each scope of work. So for this drawing, 1 inch equals 100 feet. For instance, we would literally go in and measure. So right here we have roughly 600 lineal feet of curb and gutter that we would need to take off, come over, write down, and do that for the entire drawing. As we moved along, we got away from blueprint drawings and got into colored drawing sets where you actually can see a little bit more detailed color representation of the project. Again, you complete your takeoff with the scaled ruler, again, curb and gutter. And then, once it was time for bids to be submitted, you would see this be compiled, basically a bid book, where all the blue pages in here are scope sheets where we would literally go through and for each trade, write down their scope, their quantity, and what would be expected of their bid. And then, when we received their quotes, you would see they've listed out different quantities and scopes of work that they've included in their proposal. We would then evaluate that compared to our takeoff and make sure that we're compiling the correct scope for the project.
The second technology that I'd like to talk about is ProEst, which is the estimating platform that we have adapted here recently. ProEst is a one-stop shop that will generate an estimate for us, as well as gather the takeoffs and generate reports for us to send to the owner, so that we're not using multiple platforms to do one thing. Previously, we'd use on-screen takeoff and we would generate our quantities there and have to either hand type or export them into Excel so that we could get values. Here you can see I've done some takeoffs, and I'll show you how it functions. Let's say I wanted to bid this panel. I would come in here and type electrical panel. Let's assume it's a 200 amp just for a little more clarity. I make it an each because it's a singular takeoff and my camera's in the way, but I have an electrical panel line item down here, but I can click and it will generate a 1 and it will populate that in my estimate. So as I come back to my estimate, you should see a divisional breakout that has each of the CSI divisions that are already populated with work that I've done on this project previously. But here we can scroll down and see, again, I believe my camera's in the way, I'll move that quickly. Electrical panel. I can now associate a cost to this, say it's $4,500, and it will take the cost per unit and multiply it by the unit to give me a $4,500 add here, which will then total up into this 0 division because I have not assigned it to its proper division, which would be electrical. And that runs a total up to the total estimate cost. Summary holds our multipliers, our fee value, our insurance, things of that nature. And then also, like I said before, it can generate reports, but that takes a little bit of time. What's important to know is that it will take all of the information that has been presented here and make a clean and concise page that will present that information to the owner in a flexible manner. Say we wanted to break it up by either different buildings or by job packages or by division. It can do all those things. It's just up to us to say what fits best for the project. Previously, when we would assemble bids with the use of on-screen takeoff in Excel, there's a multi-step process where ProEst is streamlined that process a little more. So I'm sure y'all are all familiar with the takeoff process for on-screen or other similar softwares of that nature. Here you can see a worksheet tab, which is what we would export after we had finished our takeoff. And you can see the quantities that I've generated for individual line items here. All this information would have to be manually input into Excel for our purposes. So I've taken the time to pull up an Excel spreadsheet that we use as well to run through it. If you pay attention, you'll notice that these aren't the same jobs, but for what we're doing, it makes sense. So here with the worksheet, again, you see all the quantities. As we move into Excel, we have what was a back of house spreadsheet where we would input the quantities and then also allocate a price to them. Also, you can see that we have our quotes input here. And the reasoning for that is that this information would be linked over to what is called our bid day spreadsheet. So this was a takeoff detail spreadsheet, which essentially is a means of inputting the information from the worksheet we had on the screen earlier, like this guy, to get it into Excel so that it was in a workable format for us. So all this information then would feed from, it would be manually inputted here off of the worksheet, and then this information feeds to our bid day, which holds the subcontractor listing essentially for the project as we see it for our pricing, and gives us our final price on the job. Now this, as well as our takeoff detail, our back of house documents is what I would call them. We have an IS spreadsheet, which is what we would send over to the ownership. So the IS spreadsheet is a document that shows the scope of work that we have included and also the cost for it, and kind of a divisional breakdown, but it has a little more detail than that. So it's not just like a division 6. It has division 6 and then, well, for example, because this is just casework, but maybe division 9 finishes. We'd have the drywall, the flooring, and the painting broken out so that we can see the individual values here. So this gives the owner a clear understanding of what we have priced and what we have included and how much it costs to do that. So the reason we moved away from Excel and the headache of it all is that we went through this triple input and like a triple check process where we would generate the takeoff and output our worksheet. We'd take that information, load it into a takeoff tab. The takeoff tab would be loaded into a bid day tab, and then the bid day tab would be loaded into an IS spreadsheet. With each iteration of that, there's margins for errors and there's room for mistakes to be made. ProEst takes away that threefold mirroring that we had to do, and it just goes straight from our takeoff to generate a report by itself. So I have pulled up a report that ProEst will produce so that we can send it to the ownership, and it has multiple different reporting types, but for our purposes here I'm going to use this one that I've pre-selected. It takes a little while to generate the report, so for the sake of time I'm running through this. Again, you'll see that it's a different project, but for our purposes it makes sense. Here you can see a divisional breakout of all the subcontractor cost, and then also our direct cost underneath it. As we scroll through this report, this one has a lot of detail. You can see each individual line item, and it essentially makes what previously was our back of house information our front of house information. You can see here some of my items have a quantity associated but zero value, and that shows the scope of work that we previously would have typed up with the IS spreadsheet. And you can see that the valuation of it is based off of a demolition crew days, but I've left my quantities to show the ownership, hey, this is what we've included in our bid.
Hey guys, my name is Chris White with Capital Construction. We're a site work company that does basically industrial, commercial type work, non-residential. To get a little bit more about site work, it's utilities, hardscaping, asphalt, concrete, grading, clearing, demolition, a lot of scopes entitled there. But we kind of cover that and specifically specialize in that. My role with the company is called Vice President of Management, so I oversee bids, have an estimator, some business development, client relations, and a little bit of management. The biggest thing I want to talk to you today is what we utilize in emerging technologies is GPS, and that's not just GPS equipment. There's a specialized portion of that, but how we do layout or use GPS with surveying, and then also with the estimating. Tie all that together. There's several ways we could talk about GPS system, but I want to also get into the nitty-gritty of construction of just how we use it versus what it's idealized for. Because there's some things that's practical, some things that are ideal, some things that are specialized maybe just to our company where other companies would use it separately. There's, as in technology, compared to a cell phone, there's several things you could use, but you only use maybe half of it. With that being said, probably want to go into estimating to start off with. So, old school way, we get a bid listed to us. We have a grading plan, civil drawing with contours. You hope that it's complete. But in the old days, essentially what we do is what we call a grid takeoff. You might have seen it, learned it in class, but you'll take it, draw this grids with a ruler on the piece of paper, or on the grading drawing. Nice even grids all the way across the paper, probably an inch apart, and then use that scale, whatever that scale is. That way, what you're doing is creating square footage for each grid. And we'll go into Excel, have each grid what it is numbered, because what you're going to do with each grid, with each square footage, is say the average amount of depth of cut or fill. So you'll have 10 squares of cut, say average of 3 foot or 4 foot. That's going to get your overall cut, and you have your fill. with all your line items, with all your grids, average of whatever depth that is, and then you'll see your overall cut and fill. So that's rough grading in a nutshell. Fine grading, backfilling, a couple of those pieces are different. But when you do your cut and fills, which is your main cubic yardage, probably what you've seen, that's what this process I'm talking about. And that is the old school way. Nowadays, technology, not just the GPS, but we use a program called AgTech. I think there's another one called Earthworks, something else, but I think Earthworks and AgTech are the main two. So what we try to do is you'll take a 2D set of plans and you'll get the CAD file, I'm trying to do this, that's going to make it 3D, because that's what you have to do, because cubic yardage is a 3D dimension. You'll take the CAD, we'll draw it out, and we can show you through AgTech, we can show what the actual takeoff, and then that way we have a true visualization of that 3D rendering. And that's going to give us all the cubic yardage. The good thing about that is too, now we can go in and there's a bunch of variables. I gave you the overall concept. There's a bunch of variables when you're estimating. You have swell factors, you have topsoil stripping, you have subgrades, you have phasing, you have spoils, and that's just to name a few. But you can kind of go in and handpick what you see what the job is and name what those variables are, and it kind of just all computes and spits out. But from there, so let's say we get the job. What we'll do with that AgTech now is what we do is create a model. And this is typically, we hire that out, we don't do this ourselves. An engineer will clean up the drawings and make it construction ready. And what he's doing is he's taking that AgTech, the CAD, and right now at the bid phase, we've just done a cubic yard or a takeoff. What he's gonna do now is add in all the other pieces of the civil drawings that we need to construct for layout purposes, what our crews need. To give some examples, those are curb lines, building corners, mostly all subgrades, all your utilities, your inverts, retaining walls, slopes, etc. There's a lot, and there's a lot that you could put on there. But you know, when you build a model, it's specific to what you need. You may not need all curb lines. You may just need just building corners and that's it. But you can put whatever you want in there and build it. So when you get this model, now you're ready to input and go do your survey and utilize the GPS system. You'll just take a thumb drive, download it, and you take this thumb drive and put it on how many units we have in the field. To give an overall sense of what this GPS is, we'll have a base station on site that's stationary. It's reading satellites. We'll have a rover, which is manual. We can show you guys what this is. The rover is also reading satellites, but you can move it around anytime, and it's got an iPad at the bottom. It's actually showing you all the layers that we developed, the model, the drawings. It's got different pages. Not only is it showing that, but with that rover attached with it, is it showing you the current grade where you're at, the proposed grade, and where you're at on the job site. It's very, very useful, so that way you don't have grade stakes everywhere. That's important. And then thirdly, piece of equipment or GPS unit you'll see on site is what you see in the dozer itself, or excavator. Some people even have scrapers, but for our purposes, we mainly use dozers. So what this is now the dozer is linked to the GPS to that base station. So the dozer knows at all times where it is on the site and how much cut you got to go, and there's a monitor inside that the operator can see. The fancy part about this, and where it really makes efficiency and money, is that now, once the dozer operator clicks in and clicks it going forward or backwards, he puts it in gear, he can hit a button, and the blade will be taken over by GPS. It will keep itself on grade and know exactly where it's at all times. In grade 2, that's really efficient. Takes a lot of operator error out. You can just see, all the time saving there is. I mean, it saves us approximately 50% what we used to do it. Huge savings, just the way you're doing things. However, there are a lot of nuances, ways of messing up, and you still have to old ways because it's not 100% feasible to do. Another problem that we see out in the field is that throughout the day, with the rotation of the Earth, the satellite angle changes, and it can cause variations. So if you know where it is throughout the day, and there's signals at the top of the rover that can tell you, you can offset that, but you got to know where they're at. We've seen problems with that surveying, aspect of it. Also, weather can affect it. The signal from the satellite to the base station. Things we've learned afterwards, but it's really good to know troubleshooting. Just more things that you've got to know this technology is not controlling, that you've got to know to offset and eventually deal with.